Welcome to The Explainer. Today, we're going to dive into a pretty fundamental process in medicine called the turbidimetric method. Now, it sounds super technical, right? But the original document it's based on, well, you're about to see just how not so technical it looks.
Okay, so right off the bat, I know what you're thinking. What in the world am I even looking at? It's a mess, isn't it? Hand-drawn lines, scribbled notes, and honestly looks more like a treasure map someone sketched on a napkin during lunch. But I promise you, this cryptic-looking drawing holds a really important secret.
Because this isn't just some random doodle. It's a blueprint. And it's not a blueprint for some old machine. It's a blueprint for the trust we all put in our medicine every single day. This is where our confidence in a simple pill actually begins.
So, to understand how this whole thing works, we first need to look at its key ingredients. You can think of it like a scientific recipe. And there are three really crucial components we need to know about.
First up, the microorganism. These are just the tiny living things, the germs that the medicine is designed to neutralize. In our little experiment here, they're the target. They're the bad guys we're trying to stop.
Next, we need something called a nutrient medium. This is essentially a carefully prepared broth. Think of it as a special soup for the germs. It's the food source that helps them grow and multiply. Without it, we'd have no way to actually measure if the antibiotic is working.
And the final ingredient, of course, is the antibiotic itself. This is the actual medicine we're testing. It's the weapon we're deploying to see just how effective it is at shutting down those microorganisms.
So we've got the germs, we've got their food, and we've got our antibiotic. Now, how do we know if it's actually any good? Well, you do it by setting up a direct head-to-head competition.
This test is basically a showdown. In one corner, we have the standard. That's an antibiotic with a known, trusted strength. It's our benchmark for quality. In the other corner, we have the test. This is the new batch, the one whose strength is a mystery we need to solve.
So here's how the competition gets set up. First, you get a starting culture of microorganisms ready. Then, you mix them up with that nutrient soup to create a kind of germ broth. You take that mixture and split it into sets of test tubes. And finally, the standard antibiotic goes into one set, and our unknown test antibiotic goes into the other. And just like that, the stage is set for our showdown. With the experiment all set up, how do we figure out who won? The answer isn't in some complicated data printout. It's actually a super simple visual clue that anyone can see. It all comes down to cloudiness.
The test tubes are put into an incubator for about 3 to 4 hours. This gives the germs plenty of time to feast on that soup and multiply. Unless, of course, the antibiotic in their tube is strong enough to stop them.
So after that waiting period, how do we actually read the results? The answer is a wonderful scientific term, turbidity, which, when you boil it all down, just means cloudiness. How cloudy is the liquid? And right here, this is the whole secret. It's so brilliant. If the antibiotic is effective, it stops the germs from growing, and you end up with a clearer liquid. But if the antibiotic is weak, the germs have a party, they multiply like crazy, and the tube gets all cloudy. In this test, it's really simple. Clear means success, and cloudy means failure.
So, after all those steps, the whole thing comes down to one simple goal. Just one. The new test antibiotic has to prove it's just as good as the trusted standard. That means the cloudiness in the test tubes has to be identical to, or even clearer than, the standard tubes. It's a straight-up pass or fail. There's no middle ground here.
All right, we've decoded the messy diagram, we get the science, but let's connect this back to what really matters. How does this simple test in a lab have anything to do with the medicine that might be sitting in your cabinet at home? Well, it all boils down to this single, powerful idea. The trust you have in a pill starts with the clarity in a test tube. That simple visual proof is the very first critical link in a long chain of quality control. This test is absolutely crucial for a few huge reasons. It ensures potency, guaranteeing the medicine is actually strong enough to work. It confirms the quality of every new batch against that trusted standard. And, maybe most importantly, it protects patients like you and me by stopping weak or ineffective drugs from ever reaching a pharmacy. It's the scientific bedrock of our trust. And that brings us to a final thought. It's fascinating to see how a simple, almost crude-looking test can ensure such a high level of safety. It really makes you wonder, doesn't it? What other invisible processes, what other messy diagrams are out there quietly protecting you every single day?